Good morning. This was not what I was expecting to do today, and this is never really easy. So I am going to try my best to get this done before 9 and get it to you. Today's a smoke day. If you are an A group and you're watching this, you don't have to. You are just responsible for the 3 assignments that were posted yesterday. Algebra Ready, Expressions in PEMDAS, Rational Number Systems. If you are a B student, you should be done those 3 assignments, and this is the lesson for square roots and operations with square roots that we would have done in class today. I also would have shown you in your class notebook, I now have posted all the pictures for your ISN. So you can go to the content library. You will see in mod 0 the pink, the pictures for that ISN and the introduction. Then if you go to mod 1, you go to the ISN pictures, you're going to see all of the blue foldables put together, and you guys were getting pretty good at putting together those little booklets. So if you want to finish that, you can do that. That's what we would have done in class today. Then we would have gone reviewing square roots and operations with square roots. So this will be in your notebook, but I'm going to go over into my notebook so you can see the notes that I would have given you if you were in class today. We would have talked about square roots. This is a radical sign right here, and under the radical sign is the radicand. That's what you're taking the square root of. So when you take the square root of something, you're finding what number you multiplied by itself to get that number. So when you look at some of these perfect squares, which is that list that I asked you to fold in front, I'm saying I have this square. It's got an area of 25. So what was the length and the width that I multiplied to get that number? And you're going to find that if you take the square root, whether you do it on a calculator or if you can estimate, which I'm going to show you in a second, you're going to find the number that you multiplied to get the number, the radicand. So 144, you can see that is a perfect square. 12 times 12 was the number that I multiplied to get that perfect square. I'm having a hard time writing on this, so hopefully I can. What was 144? Well, 12 times 12 is 144. So when I take the square root of it, my answer is 12. All right, so these are perfect squares. Those are easier. When you're approximating and you don't have a calculator, you're still looking at perfect squares. So 98 is between the two perfect squares, 81 and the square root 100. And if you start listing all those perfect squares in there, so the square root of 82 is going to be between 83, 84. The square root of 90 is almost directly between 81 and 100. So if the square root of 81 is 9 and the square root of 100 is 10, then the square root of 90 is going to be pretty close to 9.5. So when you start listing those numbers in between, you can kind of guesstimate about where the square root of 98 is going to lie. So the square root of 99 is going to be almost 10. The square root of 98 is going to be approximately 9 point, I don't know, 9192. Try it on your calculator and see if you can guesstimate. But really, you start listing those numbers and you can guesstimate where your the square root of 98 is going to lie. And it's going to be a lot closer to this 10. When you're simplifying, these square roots are like exponents. So you're going to do that before you subtract. You're going to take the square root of 225, then minus 10 in your brackets, then multiply it by 5. So it's like following order of operations, and you've got to think of a square root as an exponent. So ease. You're going to do that before you subtract. You're going to take the square root of 400 before you multiply it by 3. So try those at home, and we will go over the answers when we get back. Then operations with square uh, square roots. I'm going to list the notes and I'm going to go over some of the examples. But when you're looking at this, how do you simplify square roots? When you are simplifying square roots, you're going to see the answers will often still have a square root sign. That's because that's the most accurate way to write it. When you take the square root of 300, you're going to get a decimal that goes on and on and on, doesn't end, and never repeats. Those are irrational numbers. So we often leave a square root sign in place of that because it's the most accurate way to write an irrational number. So when we're simplifying these square roots, if you look at example number 1, you're going to recognize that each of these have a perfect square. 300, for example, is the same as 100 times 3. 3 times 100 is 300. But we know what the square root of 100 is. So this is going to be, I'm going to write on top of it and I'll erase it. The square root of 100 times the square root of 3. Same thing as the example that you were given. But you know that the square root of 100 is 10. So this is going to be the square root of 300 is going to be the same as the square root of 3 times 10. Or we can simplify it like that. You're looking for a perfect square. So when I look at 99, if I go back to look at my list, I know that 99 is the same as the square root of 9. That's a perfect square, times the square root of 11. So I can rewrite that as 3 times root 11. Gonna leave this. This is an irrational number that is more accurately written as a radical sign than the decimal that you would see. All right. So that's what, when we're simplifying operations with square roots, we often leave the square root sign there. So example 4, when you're adding and subtracting square roots, the square root of 6 is a number. It's a crazy irrational number, but it's still a number. So I can think of x. X could be the square root of 6, right? So if I replace that and I said, well, then I have 3x's plus 8x's, I can add those up, right? I have actually 11, that's combining like terms, 11 x's. So I really have 11 square root 6. So when I'm adding and subtracting, I can simplify because I can tell you I have 11 times root 6. This is like a like term, or x. So, and I'm going to erase it so you can see it. When I'm looking at this, I have 2 roots of 7, and I'm taking away 8 roots of 7. This would be, I could let x, if I think about it this way, x is the square root of 7, and y is the square root of 3. These are just representing numbers, right? So I have 2 x's, I have 9 y's, and I have 8 more x's. I can combine these like terms. So I actually have 9 root 3's or 9 y's and minus 6 x's, or I have 9 root 3 minus 6 square roots of, okay, I'm having a hard time writing this, 7. Think of these like a number that you can add up. So how many root 7's do I have? Well, I'm subtracting 6 root 7's, and then I have 9 root 3's. Try this one. So I'm going to show you right away. I'm going to erase all this so you can see it. I see a perfect square there with root 7, root 27. Okay, there's a perfect square. The root of 27, because 9 times 3, is the square root of 7. So when you try this one on your own, you first are going to simplify it and then add like terms. When you're multiplying, you can multiply under a square root. So when you have this, root 5 times root 20, that's the same as saying root 5 times the square root of 20, because it has a square root sign. So you can multiply under a square root sign. Root 5 times root 20 means you have the square root of 100. And the square root of 100 is 10. So for example 7, it simplifies to 10. But you can only multiply under a square root sign. So order of operation, or when you're multiplying, order doesn't matter. This is really going to be 7 times root 8 times the square root of 8. Right? So then when there's a radical sign, you can say this is the same as 7 of 8 times 8. Once you see these, you kind of get used to it and you will recognize what to do. So I actually have 7 times the square root of 64. Oh, wait. The square root of 64, 8 times 8, is a perfect square. Simplify that one, and we'll check those answers when you get back. Do the same thing here. You actually have, you can multiply under the square root. So this is going to be, for example, 9, 7 times 3 times the root of 2 times 18. So simplify that and see what you get. I think this is going to be another perfect square that you're going to recognize. The dividing is almost the easiest because look at this. You can see perfect squares. So you really can rewrite example 10 as the square root of 25 over the square root of 49. Those are two perfect squares. The square root of 25 is 5. The square root of 49 is 7. All right, and we're going to leave it as a fraction. Try those next two. What I'm going to have you do is write, these are the notes. These are the very complicated notes, but it may make sense now that you've seen the examples. Rewrite the product as the largest perfect squares that the radicand is divisible by, and some other factor. Evaluate the perfect square and keep the other factor inside the square root. Going rainbow. Keep the other factor, the irrational. So if it's the square root of 3, we're going to leave it as the square root of 3. We are not going to write the decimal. These are your notes. Try the rest of those answers. If you have questions, we'll talk about them when I see you next class. Oh, I hope, enjoy your smoke day, and we'll see you next week. Bye.